Okay, let's do that.
Yes, good afternoon, good evening, good morning, wherever you are joining us from. You're welcome to our webinar. That's the GBCN Knowledge Series number 3. And our topic for today is smart and sustainable, the role of digital technology in green construction. So I welcome you all. I will hand you over to our CTO, Sangeeta, to moderate the program for us. Thank you very much, Sangeeta. Please take it over.
Good afternoon, everyone. Thank you so much. Welcome to the webinar. It's a very interesting topic, and I think it will be very useful for Nigeria. And we have our speaker, Mr. Antonio. He is a specialist in an information and communication technologist and also smart buildings and city consultant. He helps clients to reimagine the built environment through the seamless integration of cutting edge technologies, including digital twins, AI powered data analytics, and intelligent performance and robotics. He's a very passionate about translating complex technological visions into an intelligent and sustainable as well as very human centric spaces. He's a very forward thinking and a result driven professional. He has over 14 years of experience of international expertise in shaping the futures of cities and buildings. He has worked across the globe. This includes in Italy, Qatar, Singapore, the UK, and UAE as well. From master planning to execution, he bridges the gaps between innovation and implementation, ensuring that every smart solutions delivered measurable value and has a very lasting impact. whether advising it on an urban scale as well as having a very individual high performance buildings. He combines a very deep technical insights with the strategies and user first approach that transform infrastructure into an intelligent ecosystem so that it can survive. So we have a very technically sound person today. I cannot wait personally to have his webinar. So I hope you all get encouraged. The other parts of it is after the presentation, you can have we'll have a Q&A session for 15 minutes. All the participants can able to question and have interaction with the users as well as myself. And apart from that, after the webinar, the presentations will be shared with all the participants. Thank you, everyone. Hope you all enjoy and get introduced to the technological side of sustainable buildings. Thank you.
Thank you, Sangeeta. Maybe before the presenter goes ahead, I want to welcome you all again on behalf of the president of GBCN, Mr. Danjuma Waniko, and to tell you about what we do at GBCN. GBCN is a membership-based organization, a non-governmental organization registered in Nigeria, and the organization was created as a response to the local and global environmental challenges caused by built environment in Nigeria. As advocate and champion of green building cause, GBCN influences and leads transformational change, promoting green building practice and urban sustainability. Our goal is to help Nigeria address these challenges through an increase in the country's stock of resource-efficient and climate-resilient building and sustainable urban growth. We are a member of the World Green Building Council and also a member of the Global Alliance for Building and Construction. With membership of these and other organizations, we are dedicated to give a platform to collaborate with global leaders in sustainable construction and amplify Nigerian voice in the global sustainable construction discourse. The vision for GBCN is to foster sustainable urban transformation in Nigeria through green building. And our mission is to lead the transformation of Nigerian built environment by promoting the creation of buildings and community that are environmentally, socially, and economically sustainable through engagement and partnership with green building stakeholders. We carry out our activity through forming activities. We do advocacy, we do education, that's building local capacity in green building. We do development, we develop standards, and we also certify product and also engage in training and local capacity to get local certification in green building. So we welcome you all to this webinar, and we hope that you will enjoy the webinar and have a cause to join us as member of our organization to join us in the assignment ahead of us that we have dedicated our life to bringing a sustainable growth to our community. Thank you very much. We can now have the presenters.
Thank you so much, Mr. Usman. Okay, so let me share my screen. Can you see my screen?
Yes.
Perfect. Okay, so first of all, hi everyone. Thanks for being here. So today we are talking about how digital technology will change the way we deliver green construction. As you know, sustainability became very, very, very important nowadays, and the idea is to design it, build it, and then keep it performing in real life. So The goal of this session will be to connect the full journey from smart cities to smart buildings, and we will show also how Nigeria can use digital to lock in real, measurable sustainability outcomes. Sanjit already introduced myself. Just want to have a quick introduction so you know where I'm coming from. I'm Giuseppe Antonio Pagin, Managing Director at Pagin Consulting. I have a background of 14 plus years of experience across smart buildings and smart cities in many countries like Italy, Qatar, Singapore, the UK, and UAE. With more than 100 projects completed in over 15 countries. So my focus sits at the intersection between building services and digital innovation. So everything regarding ICT, security, building automation, audiovisual, and so on, but also user experience, data-driven design, and integrated delivery. So the goal of my work is quite simple. I normally help developers, owners, and cities turn technologies into measurable outcomes, like, for example, lower energy and emission, safer operation, and better experiences for people that normally use the spaces. Okay, so here is how we will move through the session. I'll start with a brief introduction, then I will set the context, why, for example, this topic matters, especially for Nigeria's cities and buildings. After that, we will walk through a practical, smart and sustainable digital roadmap, which is the core of my presentation, focusing on what needs to happen across planning, design, delivery, and operations. And finally, I will close with a quick summary of the key takeaways and what we can realistically do as a next step. Okay, so let's start with the introduction. Now, before we dive into smart solutions and technology, I just want to clarify what we mean by smart, because based on my experience, it's often misunderstood. So smart, in my opinion, is not just adding shining or cool technology. It's not one size fits all. It's not just collecting data, and it definitely shouldn't be a closed system that only experts can use. So what smart should mean, especially for cities and buildings, is something much more, let's say, practical, like solutions that are people-centric, design around real needs, and supported, of course, by data that will lead, of course, to action. It has to be sustainable, connected, interoperable, and able to adapt to changing conditions. So the way I see this, the goal is not just more technology. The goal is a better outcome through the use of technologies. Now, when we say smart cities and buildings, these are the 6 capabilities we are really talking about. First, comprehensive data integration, because you cannot manage what you cannot see. Like, for example, energy, water, mobility, safety, and building system will need to connect into one single view, not sit in silos. Second, advanced analytics, turning raw data into patterns so we can spot waste, risk, and opportunities early. Third, actionable insights. So we are not just talking about dashboards, but clear recommendation that will help leaders and owners decide what to fix or upgrade or prioritize. Then there is dynamic adaptation, system that responds in real time to occupancy, weather, grid pressure, or even flooding, and many other parameters. Enhanced decision-making, which is basically the human side of this, giving city operators and facility managers the confidence to act fast using evidence, proof, data. And finally, synergistic performance, which is, in my opinion, the big payoff. When city infrastructure and buildings work together, we get better efficiency, we can lower emission, and we can achieve a better quality of life. So, in my opinion, these are not nice to haves. They are building blocks of smart that will actually support sustainability. Now that we saw these key aspects, let's see how these key aspects have an impact on green construction. Okay, let's start with comprehensive data integration. So when we connect city utilities, transport, public safety, and building systems into one single view, we stop making isolated decisions. We can actually see where energy and water, for example, are wasted across districts and assets. And that will help planners, owners, developers target the biggest sustainability goals. The second piece, as you can see in the slide at the bottom, is advanced data analytics. Now, having data collected is not enough. So the value comes when we can spot patterns, like, for example, which neighborhoods are inefficient, or which buildings are unusually high consumers, or, for example, where leaks and faults are driving up emissions. Okay, so if we put this in simple terms, we can say that integration will give us the visibility, analytics will give us clarity. Actionable insights. This is where data becomes very useful. So instead of just showing charts, a smart system will tell you exactly what to do next. Like, for example, adjust settings, change schedules, target a specific retrofit, or, for example, I don't know, fix a recurring fault. So that's how you translate complexity into outcomes, like, for example, lower energy bills, lower carbon, or better comfort. Then we have dynamic adaptation, which I believe I call it the operational superpower. Why? Because buildings and districts don't stay static. Occupancy changes, weather shifts, or, for example, the grid becomes unstable. So the smart systems can respond automatically, reducing energy, for example, when demand is low, or prioritize critical loads during outages, or keep indoor environments safe during heat waves. These are just examples. Enhanced decision making. Now, when we have reliable, connected data across cities and buildings, leader, of course, can plan easily. It becomes easier to decide what to prioritize first, like, for example, which districts need upgrades, or which buildings should be retrofitted, or where adding renewables will have the biggest impact, and in general, how to spend limited budgets in a way that moves climate goals forward faster. And finally, we have synergistic performance, which is basically the idea that buildings shouldn't be designed in isolation from city systems. So when grid, mobility, public spaces, and private assets work together, we can gain system-wide efficiency and resilience. So this is the biggest payoff. Okay, so this slide explains why smart and sustainability need to be tackled together. So on the challenge side, most cities and buildings still suffer from fragmented or outdated systems. So energy, water, and comfort data are not visible in one single place. This will force manual operations and reactive maintenance, which will drive up operating cost, downtime, and emissions. And even where the intent is green, buildings and plants are often under-optimized. So performance will fall short in real life. Now, the upside, the advantages is significant because a smart, sustainable approach will cut energy and water use, will reduce cost and carbon, and will make performance measurable. It also will enable predictive maintenance, extending asset life, and at the end of the day, improving resilience. And importantly, it will deliver healthier, more comfortable spaces that people can actually feel. So what's the message behind that? To get these benefits, we will need to structure a set of design activities from visioning and user needs, benchmarking, feasibility. We will go through that very soon in the next few slides. Why we do that? In order for sustainability to be designed, digitized, and then sustained during operations. Okay, so of course now we need to put all these things into context. So what we have done a series of research. Of course, you know, we can have follow-up meetings to better understand Nigeria's construction ecosystem. But what we found are very you know, reliable data and sources that will let us understand, you know, what is the current situation in Nigeria and the current trends. Now, what are our findings? So we understood that Nigeria is facing first explosive growth alongside an infrastructure gap. This means that a massive pipeline of buildings like new homes, offices, schools, hospitals will be built in the next few years. So the choices we make now will shape energy use, cost, and emissions for decades, basically. Second, the current trajectory is still energy hungry and carbon intensive. So without smarter planning and stronger performance standards, growth will keep pushing fuel demand and cost in the wrong direction. Third, building sits right at the center of the challenge, not just because of electricity, but because of the broader reality of inefficient systems and reliance on polluting energy sources. So what's the lesson behind that? So if Nigeria wants to meet energy and climate targets, we cannot treat sustainability as a finishing touch, okay? We need to transform how cities and buildings are conceived, delivered, and operated with, of course, digital tools supporting measurable performance at every single stage. Now, a quick note on where Nigeria is today. We already have, based on our research, we already have, a few flagships, okay? Smart city style developments like Eco Atlantic, Sanctuary City, Alaro City, and Hazana City. They show real ambition around modern infrastructure and improving digital connectivity. But the more advanced feature, like, for example, artificial intelligence or, I don't know, app-based utility management, smart grids, and so on, are still emerging, or sometimes are stronger in paper than in reality. Okay, so the opportunity now is to move beyond showcase district and build a scalable, repeatable, smart standard that can be rolled out later on citywide in order to deliver measurable sustainability. Here, I'm basically showing how we ground the smart conversation in reality. So, as we know, the market is moving very fast, and it's not easy to know what good looks like, for Nigeria today. So, what we did, we use a structured benchmarking approach to understand 4 things. First of all, the big tech trends, the socioeconomic drivers, who the market leaders are, and what kind of opportunities areas will really fit each new development. Now, the table on the right is a simple technology matrix that will basically tell you what is the current situation across the 4 development that we just mentioned. So you can see that some of the feature, smart solution and green solution are already implemented in some of, in some of these development. Some are designed but not implemented yet, and some of them are mentioned, but there are no, there is no enough documentation for us to say more. Okay, but of course this exercise is just the beginning. Of course, it needs to be improved based on on conversation with different type of stakeholders as well. Okay, so here is the, let's say, the simple way forward logic for Nigeria, the way I see it. And this is why I keep using these 3 words: conceived, delivered, and operated. First, conceived. So, as I just mentioned, and as you know, Nigeria is growing fast, and that growth is a once in a generation chance to set clear performance and digital requirement at the city, district, and building level. Before we lock in high strategy, high energy use for decades. So this is where we define targets, data standard, and the smart foundation. Then, of course, this this design needs to be delivered, right? So every money spent on construction should create smart, ready, low carbon assets. BIM, for example, can help us integrate disciplines, reduce waste, and design the building, a future-proof building, including, for example, planning for sensors, connectivity, and the digital twin from day one. Finally, the building must be operated. Okay, so this is where the biggest savings and the emission cuts actually show up. So with the Internet of Things, analytics, artificial intelligence, and a living digital twin, city operator, facility managers can actually monitor performance in real time, preventing failures and continuously tune energy and comfort. So if we don't get smart and sustainable outcomes by chance, so we need to engineer them across the full life cycle. So it's I'm trying to show you a structured approach, which is basically translated into this kind of roadmap that we could use for any type of project, like building, development, or entire cities. As you can see, this roadmap is divided in 3 main phases: conceived, delivered, and operated. And each one of these phases has some sub-activities, and we will talk about them in the next few slides. Let's start with the conceived. So before we start talking about any gadgets, any technology, any smart solution, it's important to first understand what is the vision around around Nigeria in terms of, for example, green, in terms of technology, and so on. So this is the first step that we need to tackle. So what is our strategy? So we start first by defining the wider goals for Nigeria's cities and buildings, and we can anchor these goals to very well established framework like LEED, BREEAM communities, WireScore, SmartScore, and so on. So the point is not just to, let's say, copy and paste foreign standards, okay? But we need to use them as a disciplined way to define what good looks like, for example, in energy, resilience, experience, or digital readiness. From there, we need to translate these goals and objectives into clear, smart themes, like, for example, energy and carbon reduction, health and comfort, intelligent operations, mobility and access, and sustainable infrastructure. And only then we select the technology enablers, like, for example, a common data environment, IoT backbone, AI digital twin, cloud platform, mobile application, and so on. So the message here is simple. Smart and sustainable outcomes don't start with technology, but they start with alignment. So once the goals and themes are clear, the technology will become a tool to deliver impact at city and building scale. Okay, so as you know, technology, smart solution, at the end of the day will be used by people. So it's also important to stop and think who will actually be facing this technology and this solution. So one of our let's say, main key activities is the user experience study. In fact, before we decide on a platform, sensor, or artificial intelligence, we need to be clear about who we are designing for and what problem we are solving day by day. So in this slide, we have mapped a broad set of key users across the city and building ecosystem, like residents, business, and office users, and so on. Each of these group experiences the city in a different way. But, for example, they all feel the same pain points, for example, when systems don't work, like, for example, unreliable power, uncomfortable spaces, poor air quality, safety concern, and so on. So what is the goal here? Understand the real journeys and expectation, then translate them into smart and green priorities. And this is where technologies and digital tools will come handy. So, like, for example, digital twins, IoT, artificial intelligence will help us measure what matters, will predict issues early, and will help us design services that improve comfort, affordability, resilience, and trust. So the idea is not designing technology, but designing better outcomes for all these people. So once we understand what are the main key user groups, it's also important to focus on each one of them, to understand what are their main needs and wants, or, for example, what are their main key activities. Why are we doing so? Because we don't want to design technologies just because they are cool, or they are everybody's for example, implementing those technologies. We want to design a smart solution that are actually useful for the people that will live specific spaces, specific environments. Okay, these are, for example, a couple of examples of a city government, municipal authority, and a resident. And you can see, a very high level, user persona, where we list down basically what we believe are their needs and wants, and what are their main key activities. So why we do that? Because as we show in this slide, we want to suggest smart solutions that are tailored to each key user groups. Like, for example, in this example, the city government employee, what are the, let's say, what are his main needs and wants, or what are his main key activities? Like, for example, he wants a reliable, efficient power and water services, right? He wants to monitor citywide resources using, for example, a single pane of glass, a single view. So for this reason, we are suggesting, as part of our designing, a smart use case or smart solution that talks about city utility, digital twin, and operation center, because it will give exactly what this kind of user is looking for: a digital live map of the city's power and water networks. Okay, so this is the kind of approach we use, before starting suggesting technologies. Okay. Now, of course, each smart use case and each smart solution needs to be translated in tangible technology, made of hardware or software. For the purpose of there are many technologies, of course, that we normally suggest during a project, and I'm sure there are many applicable technology for Nigeria. However, for the purpose of this presentation, we limited our study to these main 4 technology: BIM model, IoT sensor, digital twin, and artificial intelligence. We will quickly go through each one of them. Let's start with the BIM model. So if we want a smart, sustainable buildings, we need a reliable digital foundation. And that foundation is the BIM model. So just for you to know, I'm sure you do, BIM has moved well beyond being a 3D drawing tool. Okay, we start with 3D for the model, add 4D for time, 5D for cost, but the real shift for this talk is what happens next. So 6D will bring sustainability into the model, like energy and water indicators, thermal performance, material and carbon data, and all the parameters that we normally need for green certification. That means that we can test buildings, systems, and control strategies early, compare options on cost and carbon, and set measurable KPIs before we build anything. Then we have BIM 7D, which takes this data into operations. So the as-built BIM will become, let's say, the launchpad for IoT integration and operational digital twin. So BIM could be defined as the single source of truth that will make smart operations and continuous decarbonization possible over the whole life of the asset. So on this slide, I just want to make a simple point. So BIM is not just a design model anymore. It's basically the integration layer for the whole smart building ecosystem. So think of it as the building's data hub. So instead of every system living in its own silo, BIM will provide a common structure for information to connect across the life cycle. So using standards like IFC or COBE, we can make sure that the data we create during design and construction are actually used during operation. So we avoid rewriting this data from scratch. So this is why we have included BIM in the middle of this platform. So it can link to the IoT platform that collects sensor data, the digital twin that keeps a live operational view, the BMS SCADA that controls equipment, or the CMMS that manage maintenance, and finally we have the analytic dashboard that will turn all of these into decisions. So the real value is long term. When changes happen in the real building, and we detect, we will see now through IoT sensor, for example, like, for example, upgrades, reconfiguration, replacements, the digital ecosystem can stay accurate. This will reduce waste, avoids wrong decision based, for example, on outdated records, and will keep performance and sustainability on track. Okay, next, IoT sensor. I'm sure everybody knows about what an IoT sensor is. Basically, they are just small devices that measure what's happening in real life and send this data to a platform and, for example, to a digital twin. Now, we have many different type of sensors that monitor, for example, energy and power, environment, water and resources, and people and use. Okay, so if we want to, we can say that the data is the fuel of smart sustainability, and the IoT sensors are the source. Let's move to digital twin, which is basically the focus of this presentation. So let's start first saying what digital twin is not. So it's not just a 3D model, and it's not just BIM. A digital twin is a live, always updating virtual version of a real building or any other asset. The difference will be the connection. So the IoT sensor will keep it synced with what's actually happening, like energy use, HVAC performance, indoor air quality, occupants, and so on. So instead of relying on periodic reports or, for example, manual checks, we get a real-time view of performance and risk as well. And this is where sustainability becomes very, very practical. So with the digital twin, we can spot waste early. We can test improvement scenario before spending real money, and continuously tune operation in order to cut energy, carbon, downtime without sacrificing comfort as well. So if we want to connect all together, BIM will give us the, let's say, the blueprint. IoT will give us the live signals, and the digital twin becomes the operational brain that we can use every day. Okay, so here I'm showing the digital twin ecosystem for a smart building. And the key point I want to highlight is that the digital twin is not a one tool, it's a connected stack. So it starts with the BIM model, which will give us the structure asset data, like, for example, what the building is, where systems are, and how they are supposed to perform. Then we have the physical equipment and IoT sensors, which will capture what's actually happening in real life, like energy, water, air quality, occupancy, and so on. This data will flow through the data collection layer into the digital twin platform, where it is organized, analyzed, and turned into real-time models and insights. And finally, there is a user interface where city operator and other stakeholders can see performance, they can get alerts, and they can make decisions. So the message will be: BIM provide the foundation, IoT will provide the evidence, and the digital twin platform will turn all of these into an actionable day-to-day, smart and sustainable operations. Here, I'm basically showing the logic of a digital twin as a sustainability engine. So how we go from raw data to better green decisions. So first of all, we start with capture and model. So BIM will give us the structure baseline, like for example, what the asset is, what's made of, and what good performance should look like. Then we have connect and integrate. So we link IoT sensors, meters, BMS, any other city systems like energy, water, indoor air quality, and so on. So they all flow into one place as a true single source of truth. Next is analyze and optimize. So this is where the cloud and artificial intelligence add real value. Like, for example, spotting inefficiencies or predicting failures and also testing what-if scenarios before we spend money on site. And finally, act and improve. Like, for example, adjusting controls, schedules, and maintenance priorities. So the infinity loop that you see at the bottom can be summarized in the, let's say, 5 main words: sense, model, analyze, act, and learn. So this is how digital twin will turn buildings and districts into continuously improving lower carbon assets. Okay, so last is artificial intelligence. Now, I think we should first clarify what is AI. Okay, because when we say AI, we often picture something mysterious, but in reality, it's software running on hardware that will learn patterns from data and will help us make better decisions. So on the hardware side, you can think as the, let's say, the muscle, okay, like servers, GPUs, cloud platforms, and sometimes edge devices within the building. This is where the heavy computing happens. On the software side, that's the brain, like the models and the algorithm that learn from historical and real-time data. And in the building, what are they learning? So things like, for example, energy use, comfort patterns, occupancy, equipment behavior, faults, inefficiencies, and so on. These are just examples. So the key point is AI will become very, very valuable when it's connected to real operational data. And this is exactly what the digital twin will provide. Together, AI and digital twin will help us run the buildings in a cleaner way, cheaper way, and more reliably. So not as, let's say, a one-off upgrade, but as a continuous improvement engine. Okay, so this slide is really my big picture view of where artificial intelligence will add the most value in green buildings, especially when it's connected to a digital twin. So first, operations and energy performance. So this is the day-to-day win. So artificial intelligence will use live data to fine-tune HVAC, lighting, peak demand, or even water systems. The result will be lower bills, lower carbon, and better comfort. Second, asset health and maintenance. So instead of waiting for a breakdown, AI can detect faults early, predict remaining life, and will help plan maintenance and replacement. This will reduce downtime and cut material waste over the life cycle. Third, design, retrofit, and scenario testing. So the twin will basically become a safe sandbox. So we can test low carbon design options, we can compare retrofit packages, and we can stress test the building against heat waves, flooding, or grid instability, and so on, before we actually spend money on site. And fourth, portfolio and district optimization. This is where AI scales. It will help coordinate multiple buildings, forecast carbon and energy budgets, and also strengthen ESG reporting. So what I want to say is AI is not just one feature. It's the intelligence layer that will help digital twin drive real sustainability outcomes from a single building to an entire city district. So we just completed, the main 4 technology enablers. Okay, let's see now how they all work together. So this slide basically summarizes that. We start with IoT sensor, which are, as I mentioned before, let's say the eyes and ears of the city or building, capturing what's actually happening in terms of energy, for example, water, comfort, occupancy, and so on. Then this data will feed into the digital twin, which is essentially the living model of the asset. And the digital twin will basically turn scattered data into one coherent picture of performance, so we can see what's working, what's not working, and where, for example, waste is hiding. Then we have artificial intelligence, which basically is a layer that will sit on top of the digital twin. It will read the data, it will spot patterns, predict issues, and at the end, we recommend the best action, or sometimes, if it's allowed, even automate some tasks as well. So the key idea is the sensors will measure, the twin will, let's say, organize all this data, AI will optimize, and then, as a result, the real world will improve. Now, if it's a building or a city, it doesn't matter. So this slide, now, if we want to give a name, let's say, to all these technologies that we just mentioned, we can call it, for example, AI-powered digital twin, okay, which is a decision engine which will sit basically at the intersection of what actually makes a building sustainable. Okay, so we are bringing together 3 big domains here. First, the building systems and equipment, the mechanical and electrical heart of the asset. Second, occupant experience and comfort, because a green building that people hate to use will never perform as intended, okay? Third, we have energies and utilities, where most of the operational carbon and cost live. So what I like here in this slide is the overlap logic. So when systems meet comfort, we can get reliable, healthy spaces without the waste of, for example, overcooling or overheating. When systems meet energy, we can get efficiency and life cycle intelligence, like, for example, fewer failures, longer asset life, or less material and replacement waste. When comfort meets energy, we get well-used, low-impact spaces that will support well-being without driving consumption up. And right in the middle is the point, which is the AI digital twin, which will turn this trade-off into daily measurable improvements, like, for example, reducing energy, water, cost, carbon, and keeping performance and comfort stable. So this is exactly why smart and sustainable should be treated, in the same conversation. Now, some of you may wonder, how this AI-powered digital twin works. Okay, so here I'm basically showing through a graph how, the basic functionament. Okay, so we start on the left with the smart infrastructure steps. First, the idea is to identify the city building assets that we want to manage, like, for example, district cooling, lighting, electric vehicles, renewables, and so on. Second, we confirm the data sources already in place, like SCADA, BMS, and other systems. Third, we close the gap with the right data collection from meter, sensor, and system data. And fourth, we do let's say, the hard part, which is the integration part. So everything, all this data will speak the same language. The key idea is this shift from on-premise to cloud as well. So we bring operational data into a structured repository, then layer analytics and AI on top of that. On the right side, you can see where the digital twin becomes an engine. So it will constantly absorb real-time and historical data. It will learn patterns and will turn everything into these actions as well. So this is what unlocks the use cases that we mentioned at the beginning of this presentation when we set up the vision. Like, for example, energy and carbon, health and comfort, intelligent operation, and mobility, with, of course, room to scale into future services. So, as you can see, there is still a connection between the technology that we want to implement and the, let's say, overarching vision that we set at the beginning of the project. Now, of course, this technology like AI, digital twin, IoT sensor, have a specific job depending on the smart use case application that we are considering. As you remember before, I was listing down some smart use cases specific for this kind of user. Now, the idea, I just want to mention that based on the type of smart application that we are analyzing, IoT, digital twin, and AI will perform in different way. Okay, so there will be, for example, specific IoT sensor for one smart application, and then this sensor will differ from other smart applications, and the same conversation is valid for digital twin and AI. So their function will perform differently based on the type of smart use cases that we are analyzing. I'm just concerned about time, so I will just scroll these other examples, but the idea remains the same. Now, Now, of course, this approach should be followed for all the smart use cases that we want to develop for a project, and for all the key user groups that we have identified in the early discussion of the project, in order to ensure that all the key users are actually getting specific outcomes. Okay, let's see now how we deliver, the design part that we just explained. Okay, so the idea here is if we want smart and sustainable outcomes in operation, we need to design and build from them for truth. Then the goal will basically be to create a high quality as-built BIM, because that becomes the foundation of the operational digital twin. Then second step is to add smart and sustainability overlays. So we run energy and comfort simulation directly from the BIM in order to shape a low carbon, high comfort design. We also use quantities to assess embodied carbon and material circularity as well. And at the same time, we also plan for digital infrastructure like sensor locations, meters, Wi-Fi, BMS, SCADA, and so on. So delivery is not just handing over a building, it's handing over a building that's digitally ready to perform. So all the buildings nowadays should be digitally ready. Now, here I'm basically laying out the simple logic for how we actually deliver a smart, sustainable city or a building without ending up with disconnected smart islands. Okay, so first we will need to set the rules of the game. That means agreeing on the vision, sustainability targets, standards, and most importantly, data requirements. So every project is, let's say, working to the same playbook. Second, we build the backbone first. So we design and implement the city's infrastructure, like networks, platform, governance, and key utility systems. So buildings have something to plug into. Third, we prove all of these in a real place. So we create a pilot district where buildings and public realm are fully connected. We can test the use cases end to end, and we can validate the benefits of these solutions. And finally, we can scale by phases. So we take what works, we refine the guidelines, and we can roll out area by area. This is basically how we believe things should be done. On this slide, I just want to show you that smart and sustainable delivery only becomes real when it's documented, procured, and also verified. So we can have the best vision, we can have inspiring use cases, but if we don't translate them into documentation like clear guidelines, coordinated drawings, BIM model, detailed specification, the project will not be buildable or measurable. So it's also important to double check, who is actually implementing this kind of solution from a contractor side. So the idea is to check the pre-qualification document, tender questionnaire, and reviewing also contractor submission in order to make sure that whatever has been designed is actually implemented on site. And finally, we need to validate the smart functionalities in a building and in the city, right? So what we hand over is not just compliant on paper, but it's actually working. And finally, operated. So how the building is operated. This is, let's say, a summary of what I believe should be done. So the first thing is simple. So we need to set the targets. We need the clear KPIs for energy, carbon, water, and so on. Then we align the digital model, like keeping BIM, the asset register, and the digital twin all in sync. Once this foundation is solid, we can run, let's say, the daily, as I call it, sense, think, act loop, meaning the sensors will feed the twin, AI will spot the patterns, and we tune set points, schedule, and sequences against the previous KPIs that we established. So we can also shift from reactive to predictive maintenance, catching up faults early and avoiding breakdowns as well. Very importantly, to avoid drowning in alerts, we operate by exception, meaning dashboard highlights only what really impacts carbon, cost, or comfort. Let's not forget also people, because occupant engagement will help turn insights also into better everyday behavior as well. Finally, we review and improve, comparing performance to design intent and scaling what works across the other buildings and districts. And then, we start again. This is like a circle. Now, I believe this slide is very powerful because, I strongly believe that technology is useless without capacity. So we can have the best IoT, the best digital twin, and AI in the world, but if the people running the city and buildings don't have the skills, the value will never land. Okay. For example, on the city side, operator will need to function like a real, let's say, control room team, meaning reading district dashboard, using city scale digital twins, and running scenario tests like heat waves, flooding, grid stress, and so on. And then they will need to turn these insights into better policies, investment, and emergency plans. On the building side, facility managers will need to evolve from reactive fix-it roles into data-driven operators. That means understanding analytics, prioritizing alerts, or tuning set points and schedules seasonally, and using digital twin for training and incident review. So the job of the city operator and facility manager will need to change as well. And none of these will stick without the right governance and culture, like, for example, clear roles, KPIs, and incentives aligned with the actual performance. So the message will be smart and sustainable outcomes come from people using data every day, not just installing technology. Installing technology is just one step. Okay, so we almost ended our presentation. The question that I want to ask you is how can Nigeria harness BIM, digital twin, AI, and IoT for a smarter, greener growth? So based on what we saw, even during our research and our benchmarking, we strongly believe Nigeria is in the right time to start using this kind of tools. So the real question is not whether to adopt AI, digital twin, or IoT, but where do we start and in how we do that. This is a small facing approach that I'm suggesting, and of course, this is just a beginning of what can come later. But the idea is to start by setting a clear baseline, like for example, mandate or at least strongly encourage BIM for major public projects with especially 6D and 7D requirements. So energy, carbon, and operational data will be built in the system from day one. Then we shift design thinking to smart ready buildings. That means we don't add technology later as an afterthought, but we embed sensor, networks, and open protocol since day one in the design. Next, we need to prove all of these through a small set of serious pilots, like for example, in an hospital or a commercial building, office, university campus, and so on. And what this project should have is IoT, of course, sensors, which is the data, a simple digital twin, and also a basic AI optimization, which is linked to real KPIs. Finally, we codify what works. So we update guidelines and standard specification, so every next phase will benefit from these lessons. And the scaling will become eventually cheaper, faster, and more consistent across different cities. This is basically a summary of what I just explained in the past 60 minutes. So the idea is to create data based on actual user needs and wants. We create smart applications, smart use cases that are tailored to user. Okay, and then of course we start engineering all of these, translating these use cases in actual technology, hardware and software. We integrate all the systems on site that are embedding this kind of data, and we create this brain, digital twin, where on top will sit AI that will help facility managers and city operator to get insights from the building on everyday basis. There are lots of benefits. I mean, some of you might ask, why are we doing this? There are just too many benefits to ignore the potential of this solution. Like here, they are just example. Like for example, attractive investment and economic value. The city asset, the building will just increase their value, but most of all, we will gain in operational efficiency. We will save costs. We will have assets that are driven by data. We will have, of course, a better citizen and occupant experience. We will improve sustainability, as we mentioned many times, and we will create a resilient and future-ready building or cities. This is my last slide, and look, we said many things, but this is really my way forward slide. So the takeaway that I would like you to remember from this conversation. So for modern buildings, sustainability cannot be a one-off design achievement. It has to survive real life. Like, for example, changing occupancy, aging equipment, rising energy cost, and tougher climate condition. And this is why I'm saying that a building cannot remain truly sustainable over its life unless it is also smart.
Mr. Anthony,
thank you so much.
Thank you. Thank you so much. I think I really enjoyed the webinar. I'm sure the participants as well. I think it clearly defined what smart buildings as well as the buildings as well as cities can do, and as well as it created through, I think the way you integrated to the Nigerian context, it made much more sense to us. I was really intrigued and I learned a lot of things. I'm sure our participants as well. I would like to now give a break for yourself and then ask a couple of questions. I think there's some couple of questions in the Q&A. If you're ready, I can actually start with some questions.
Yes,
That
please.
the first question is, Mr. Williams, in order to determine the effectiveness of dynamic adaptation, what are the parameters and measurement of a smart building? I think when it talks about very building or higher performance building alone, I think any 4 or 3 key parameters of measurements that we can do that will determine a smart building. Will that be okay?
Okay, so I mean, I think when we want to design a smart building and we want to have, let's say, a very fast effect, on what we are actually suggesting, we need to, of course, tackle some smart solution and technologies that will help, for example, decreasing the energy consumption on site, and also to decrease the operating cost throughout, for example, the building asset lifespan. I think, and also third, you can do all these again if you have an integrated environment that will basically connect all the systems and data within one single, let's say, common data environment. There are different type of way to say that, but once you have all this data in one place, you can easily, let's say, start creating smart use cases and solutions that enhance efficiency on site, reduce cost, and you make basically a building or a city future proof. Okay.
Oh, that's great. That's great. I think Mr. Williams has another question as well. I think it talks about green financing in actualizing smart buildings. I think one of the key hindrance we have in actualizing a smart building is that it is very economically intensive. So it's capital intensive, and that's, I think that is the only thing. I think that is one of the key problems that we are facing in Nigeria, because like the investment is really high. And I think the other thing he's asking is, what sources will Nigeria be able to utilize properly to achieve smart buildings?
Okay, so that's a good question. So, uh, and I keep receiving this question from many clients, but I can actually say that introducing smart technology and planning for a smart infrastructure is not too expensive as it may sound. Okay, so what I normally tell all my clients is basically to divide this, let's say, exercise in 2 parts: building a smart infrastructure and start developing more use cases and more solution as a second step. When I say smart infrastructure, we need to create the foundation of smart, which is basically, as I mentioned before, try to understand how the building is performing through the installation, for example, of sensor, because sensors are the technologies that will give us the data, the actual condition of the building. Sensors are not expensive, okay? So they are very, very cheap. And then second, as I mentioned before, you will need to do an engineering process to convert data coming from different sources like building management systems, security, IoT, and you need to let them talk one single language. So you need to structure all this data in one, using one dictionary. Okay, this is if we do that from day one, it will help you creating smart use cases, a smart application on day 2 when you have, for example, more funds, you have money to invest. But in order to not to waste money later on, upgrading the infrastructure. So what I normally suggest to clients, and I think it will work for many other developers, is to do these main 2 things: get the data from the building, normalize them, okay, create just 2, 3, 4 probably use cases that have a very huge impact on return on investment. And then later on, when there are more funds, we can build upon this infrastructure.
Yes, I think that's a very practical advice, I believe, because it is very important. I think, as you mentioned in your last slide, it is very important to build buildings to be sustainable over the period of their life cycle. It is important they have smart technologies integrated on it. I think the third question is about the metrics that is used. So I think the question that he means is, if you say it's a successful sustainable building, what are the metrics that is being used, that is being measured by the technology, to know that it is successful?
Okay, so this is it depends, okay, because if you remember during the vision, we explained some, we need to get some major outcome out of it. Like, for example, what we want from this project. Do we want to, let's say, reduce energy consumption? Do we want to improve, environmental quality and so on? So we need to set specific targets. Now, once we do that, we need to create some key performance indicator that will actually help us monitoring these outcomes. And we build smart use cases that will actually help us monitoring these key performance indicators. Okay, but this is a process that you start during the design. You build customized dashboard that will show you these KPIs basically every day, 24/7. And then after implementation, you can actually see, you can compare, for example, the old version of this building with the new version where we have smart technology embedded. Okay, so it's a great question. So during design, what we do, we normally set a long list of KPIs that we embed into the design, and we keep monitoring this KPI and basically forever through platform, digital twin platform, and so on.
Yes, I think it's very key to, as a project team, to determine their green goals.
Exactly.
So what is the goal they wanted to achieve in that
Yes.
buildings? So once you set up your goals, it's very important to assign a KPI, and then you can measure the success. And think with this digital technology, it is very easy to measure what you
Exactly.
manage. So that's perfect. Okay, this is another Williams. I think the difference between smart buildings and green buildings. I think it's basic. So I think I can save you time. I think smart buildings are about technology and automation that makes us efficient use of the user as well as the building space, whereas green buildings more aligned to the environmental impact and the building footprint of a building. I think a building can be both green and smart to be a complete sustainable building, I would say. I think the next question, which I have no idea, Antonio, you have to help me. What is the life cycle of an IoT sensors and how they are maintained during the life cycle of the building?
Okay, so basically, you install the sensor from day one because it helps you getting the data. I don't know, from mechanical, electrical equipment or environmental monitoring and so on. And then once you get the data, of course, you need to let's say integrate this data into some let's say, I want to call it, let's say, a brain, a platform, a digital twin, because you need to. Sensor will just help us to get the real condition of the building. That's all they can do. They can tell us if the an equipment is not performing very well, or for example, they can give us occupancy. But then there should be a brain behind that that basically explain, implement what this kind of data should be should do, right? For example, we can use occupancy data to improve HVAC settings based on occupancy. Okay, so IoT sensor is just let's say a tool, okay, but the main work will be done by platform behind that. And Sanjita, if you don't mind, I want to add something to the previous question. So what I wanted to get out from this presentation today is that I don't think we can actually differentiate sustainability from smart, because I keep working with the sustainability consultant, okay, and there are just too many overlaps between smart and sustainability, because especially the smart solution that I just mentioned in this presentation will clearly push sustainability so much, and it can help developers and owners achieving certification like LEED, BREEAM, and so on. So I can say that they are very well connected.
Yeah. Thank you for that. I think we just got 4 minutes. I will take the next two questions. I think one is from Chiamaka, that how does all these work during construction? Yeah, I think it's a very practical question. Or
Yeah.
is it included in the structure after the construction, like technologies?
No. Okay, so normally, once we list down all the smart application that we want to propose for this project and they are approved by the client, we need to set up a procurement strategy. So we need to tell the client what are the technologies that needs to be installed from day one. And those, like IoT sensor, I can tell you they are a must. Okay, those needs to be embedded, in the construction since day one. Okay, but then there are other type of technologies like software and so on that could be installed later on, like 6 months, after construction, or 1 year later. So to reply to that question, it depends on the procurement strategy. We need to define the technologies that we propose, and let's say segregate them in different category, like day one smart feature, day two, and future technologies, in order to set clear instruction to the constructor what they need to procure during construction and what they need to install.
Thank you for that. I think the last question will be from Ms. Asma. Are there any existing tools to put all the parameters you mentioned in one place?
Yes, of course. The digital twin.
Yes.
Yeah.
Yes,
So
I think
basically,
that's the question.
yeah, imagine all the building data going to digital twin, okay, which basically will run a specific algorithm and software that will help, for example, developers and clients in general monitoring specific KPIs. Okay, it's all connected. So based on the KPIs that we establish, we can create bespoke dashboards into the digital twin. And then there is AI on top of the digital twin, which will make everything smarter, because it will learn every year, what's happening, in order to let's say to make decision smarter and easier for city operators and facility managers.
Oh, that's perfect. That's perfect. I need to apologize to Mr. Francis and Mr. Toby. Sorry, we couldn't take your question because of the time. I should at least take a minute to appreciate and thank Mr. Anthony Penguin for taking this wonderful session. We are very grateful that you took time out of your busy schedule to educate us in this digital twin and technology. It's really inspiring because we can see that this is going to be the future. Sustainability is going to be the future, and especially the technology that gets into it. So this has been a great eye-opening session. I'm sure the participants have enjoyed. We will come back with the feedback of the webinar as well as, and I promise all the participants, yes, of course, the presentation slides will be mailed to you after this webinar. And thank you so much, Mr. Guzabi. Please, I will ask Mr. Usman to close it for us, please. Thank you.
Thank you.
Yeah. Thank you, Mr. Anthony, for the brilliant presentation. And I want to believe that the participants have learned a lot today. And from your slide, I'm sure they will still learn more. If we have any other question, clarification, we have your contact. They will surely reach out to you. Thank you very much for for coming on our platform to give us this knowledge. And we hope that everybody here present today have learned one or two things on what smart building is all about, the tools that we need to use, and how we can integrate them to achieve sustainability in our building. Thank you very much, Mr. Antonio. Thank you everyone for attending today. GBCN is open to membership. We want you all to, if you are not yet a member, you can go through our website, look at what we do. I'm sure they will be interesting to you and you can join us. We are at gbcn.org.ng. Check us out, and we'll be willing to welcome you on board. Thank you very much. Have a lovely day, lovely evening from wherever you are. Thank you very much.
Thank you so much, Mr. Usman. Thank you, Sanjita. Thank you, everybody.
Thank you.
Bye-bye.
Bye-bye. Thank you.